Hello everyone, welcome to Ganesh Gurukul and this is Yogesh Garg. In this video, we are going to discuss JEE Mains 2021 26 Feb evening shift numerical value type question number 4. So this question is based on the concept of integrals. Though this question is a part of mains, but this question is certainly of advanced level. That's why this question is a part of the series mains is main. So let us start the question. We have Imn, that is integral mn 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx, and we have one more expression of that much of complexity, and it is equal to alpha into Imn, where alpha belongs to where alpha can possess any real value. Then alpha is equal to, and the answer is in the form of numerical value. Now first we have to figure out that how to relate this Imn with this particular expression. Fine. And what we can observe that this Imn also one more thing, we have a property a plus b minus x, right? Integral of fx a to b fx dx is equal to a to b f of a plus b minus x dx. So we have this property, and with the help of this property, we can observe that this Imn can be written as this Imn, which is 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx is equal to integral of 0 to 1 1 minus x to the power m minus 1, and apply the same property 1 minus x over here. Fine. 1 minus 1 minus x, 1 minus 1 minus x to the power n minus 1 dx, and through this we have second expression as 0 to 1 1 minus x to the power m minus 1 and 1 minus 1 minus x, that will be x only, x to the power n minus 1 dx. So these two are the same expressions for Imn. Fine. Why I am writing this? Why I am writing the two different expressions? Because what we have to do, we have to convert this expression. We have to convert this Imn. We have to use some substitution in this Imn to convert it into the given expression, right? So we have two expressions for Imn, two different expressions for Imn. Now what should we do with this Imn so as to make it in the required form? We can certainly observe we have to remove this 1 minus x. Also we have to remove this 1 minus x, and we have to bring this 1 plus x in denominator. Now what we can do? Just think of this. What we can do? We have to bring 1 plus x in denominator. That is for sure. If, let us say, substitute x by 1 plus t. Substitute x by 1 plus t. And why I am saying this? By 1 plus t, not 1 plus t, by 1 by 1 plus t. By 1 by 1 plus t. Now what is the rationale behind this? What is the logic behind this? Let us say I substitute x by 1 plus t in Imn. Okay, so Imn was let me bring this expression downwards. So this is Imn, right? This is Imn. Replace x by 1 plus t. Okay, so we will have, by replacing x by 1 plus t, we will have Imn m comma n is equal to integral. What will be the limits? So when x is equal to 0, t must be equal to, if I am saying x is equal to 1 by 1 plus t, and the initial limit of x is 0, how can a value like 1 by 1 plus t is equal to 0? When it can be equal to 0, 1 by 1 plus t? When t is equal to infinity. So it means lower limit of t will be infinity. Similarly, when does this certain value 1 by 1 plus t is equal to 1? when does this value 1 by 1 plus t can be equal to 1? 1 by 1 plus t is equal to 1. I hope everyone can understand this. When t is equal to 0, so upper limit is t is equal to 0. Now x to the power m minus 1. First expression is x to the power m minus 1. So replace x by 1 plus t. So 1 by 1 plus t to the power m minus 1. So in denominator we have 1 plus t to the power m minus 1. Then second expression is 1 minus x to the power n minus 1. 1 minus x. X is 1 by 1 plus t. Sorry. 1 by 1 plus t to the power n minus 1. And what will be dx? If x is 1 by 1 plus t, dx will be minus 1 by 1 plus t whole square dt. Dx will be minus 1 by 1 plus t square dt. So replace it. So minus, we can take minus outside, and we have dt by 1 plus t whole square. You will be amazed to see that the final expression will be of the form of required expression. Will be of the form of required expression. Let me solve this. So it will be equal to, this is minus, and we have limits infinity to 0. I hope everyone can relate to this, that if we have a minus sign outside and the limits are b to a, limits can be written as a to b, but we have to utilize this minus sign. So utilizing this minus sign and reversing the limits, we will have 0 to infinity 1 by 1 plus t to the power m minus 1. Taking LCM in the second expression, we have 1 minus 1 by 1 minus 1 by 1 plus t. Take LCM, you will get 1 plus t minus 1. 1 plus t minus 1 upon 1 plus t. Fine. 1 plus t minus 1 is t. So t to the power n minus 1. And in denominator, we will have the same term, 1 plus t to the power n minus 1. Then we have dt by 1 plus t whole square. So eventually we have 0 to infinity t to the power n minus 1 dt, and in denominator we have what power we will have of 1 plus t. 1 plus t has power m minus 1 in first term, n minus 1 in second, and 2 in third. If you multiply these three bases, if you multiply these three expressions, power will get added up, and final power will be m plus n. M minus 1 plus n minus 1, m plus n minus 2 plus 2 m plus n. Fine. So in denominator we will have 1 plus t to the power m plus 1. Now just look at the required expression. X to the power n minus 1 by 1 plus x to the power m plus n. Fine. And also, though we have x to the power m minus 1 as well, and the limits are 0 to 1. These things are also which we need to consider. But we have a sort of expression, right? There's a issue of limit, and there is one more issue. We need to have t to the power m minus 1 as well. We have t to the power n minus 1, but we need to have t to the power m minus 1. Now how to figure out that, or how to make this expression, or how to find the term of t to the power m minus 1? You know, while starting the expression, while starting the question, I showed two different expressions for the same IMN. IMN is the given expression is IMN. I used a plus b minus x to make it in the other form as well. So I will take the help of second expression. And convert it also in the form of t to the power maybe m minus 1 or whatsoever we can have. So second expression is this, integral 0 to 1 minus x to the power m minus 1 x to the power n minus 1. है ना? So using this expression, we will use this expression and we will substitute the same thing. We will do the same substitution. We will replace x by 1 by 1 plus t. Fine. And what you will get, we need not to solve it. Just understand the pattern. See, 1 minus 1 by 1 plus t, you will take the LCM. In numerator you will get t to the power m minus 1. That's all that will make the difference, right? So from this, from the same imn will also be equal to integral 0 to infinity. If you have any confusion, you can solve it by yourself by using the same process that I had just done in the first part. But it will be equal to the this particular expression which I am writing, 0 to infinity t to the power m minus 1 dt upon 1 plus t to the power m plus n, right? Though also we know that the variable does not matter in definite integral. Okay, so if you add first and second, this is, let us say this is first and second, just add first and second, adding first and second. Oh, I know there is an issue of limit that we will consider in the second part. So add first and second, add first and second. On left side you will get 2 into I mn is equal to 0 to infinity, limit is same, denominator is also same, 1 plus t to the power m plus n, fine, and we have t to the power n minus 1 plus t to the power m minus 1. Again, there is no issue of variable, whether you write t or x, it doesn't matter, into dt. Now the whole problem boils down to the issue of limit that we need is 0 to 1, and what we have is 0 to infinity. So there is this issue of resolving the limit between 1 to infinity. That is, we can break this expression in two different parts, in two different limits, right? We can break this in this manner. We can break this expression in this manner. Zero to 1 t to the power n minus 1 plus t to the power m plus 1 into dt by 1 plus t to the power m plus n. This is what we need, but we cannot go ahead with this, right? We have one more part, that is 1 to infinity and the same expression, and that is the last point of contention, right? This is the last point of contention which we need to resolve. I hope this screen is visible, or let me scroll it down. Fine. So this is 2imn. First expression is perfect. We are perfectly fine with this. Now how to resolve the issue of second expression? We need limits 0 to 1. We need limits 0 to 1. Just think about it. What we can do? What we can do to make this 0 to 1? There's only one thing. To convert infinity into 0, there is only one thing, and that is replace t by 1 by y. Replace for second part only, right? For second part only, replace in second part, which I have enclosed with orange color rectangle. Replace t by 1 by y. Fine. By doing so, the limits of y will be 1 to 0. Again, there will be a zero negative that we will have from dt, and we will reverse the limits. Okay. What I am doing right now is converting the second expression to the desired form. So we have 1 to 0, right? T to the power n minus 1, that will be y to the power 1 minus n, plus t to the power m plus 1, and that will be y to the power 1 minus this should not be m plus 1, this should be m minus 1. I'm sorry, this should be m minus 1. So y to the power, I hope you are getting this, t to the power n minus 1 will be y to the power 1 minus n, because we are replacing t by 1 by y. So second term is 1 y to the power 1 minus m. Fine. In denominator we will have 1 plus y. We will have 1 plus y by taking the LCM. Though the y in this particular term, this is 1 plus 1 by y. So that 1 by y will be raised to the power m plus 1, m plus n, and it will go into numerator. So it will be multiplied in numerator in this particular manner, y to the power m plus n. In denominator we will have 1 plus y to the power m plus n, and dt will be minus 1 by y square dy. So minus can be taken outside. We have 1 by y square dy. I hope, again, I'm sorry if the screen is not visible. I'm just calling it up. I hope it is now visible. So this is the expression, right? First, we are perfectly fine with the first term. We just the point of contention is the second expression, and I will resolve it. We will resolve it. So we have the second term. Second term. Now, moving ahead, this minus sign is used to reverse the limits. So second term, second expression can be rewritten as, we can write it again as 0 to 1. Now this y to the power m plus n can be multiplied with both the expressions. Also we have y square in denominator. We will use that also. Fine. So let me write this like in this particular manner. This was dy by y square now. So can I write this minus 2? I hope it is clear to everyone. It was y square in denominator. If I transfer it in numerator, we just need to subtract the power, right? So minus 2 in the power itself, dy outside. Multiply this with both the terms, y to the power m plus n minus 2 multiplied with y to the power 1 minus n. Minus n plus n will be eliminated. M minus 2 plus 1, it will be y to the power m minus 1, and then what we need. So this is y to the power m minus 1 plus y to the power 1 minus n multiplied with m plus n minus 2, power will get add up, n minus n eliminated, m minus 2 plus 1, I'm sorry, it should be 1 minus m over here. So 1 minus m plus m get eliminated, n minus 2 plus 1 will be n minus 1, so y to the power n minus 1, and in denominator we have the term 1 plus y to the power m plus n, and there is this dy, and the variable does not matter. So finally we have 2imn. These two are the same terms. This blue expression, this orange expression, they are the same terms. I hope you are getting this. Variable does not matter. Finally what we can write is 2imn is equal to 2 integral 0 to 1 x to the power m minus 1, because variable does not matter. They two are the same terms. This orange color expression and that blue colored expression. X to the power m minus 1 plus x to the power n minus 1 upon 1 plus x to the power m plus n into dy. 2 get eliminated. So we have imn is, this expression is equal to imn. This is equal to imn. And the question was, this is equal to alpha mn. So this is equal to imn. What must be the value of alpha? 1. Value of alpha was 1. So this was a question, and I will definitely agree with this, that this question was a good question. It was not at all. It was not at all a easy question. It cannot be called as an easy question. It is a difficult question. I would say it is above average question. And also there is no harm in seeing this question as difficult question. In exam, it is certainly difficult. It is difficult to figure out that we need to replace x by 1 plus t. It is difficult. Also, it is difficult to break this in the limits, to perform this particular thing, to break this 0 to infinity, 0 to 1 and 1 to infinity. Although I agree that after this 1 to infinity, it was not that difficult to comprehend that we need to replace t by 1 by y. But these all things, they can be said outside the exam hall, right? But in exam itself, it all boils down to what strike in the first instance, right? What hit you in the first instance. So I would say this question is difficult. Without any hesitation, this question is a difficult question with respect to the examination. But it is a good question. It is a good learning, because there are chances that this question can be repeated in any of the examination, be it JEE Mains or say any state engineering entrance examination. So I would say that do this question multiple times, as many times as possible. At least 2-3 times you should solve this question from very first step to the last step, and you should understand all the process, what I would say, all the steps involved in it. Fine. So keep watching Garit Gurukul, stay tuned, and we will meet in more videos.